my name is Eva.
And I'm Evan.
We are researching with D.L. Lundberg and Dr. Julia Devoy on engineering a bioreactor using principles of frugal innovation. Have you ever felt frustrated with the unnecessary expense of scientific equipment? We have too. We wanted to measure the effect of textile degradation on the environment to highlight the detrimental impact global waste trade has on level 1 countries. But the cost of a bioreactor, a common tool for biodegradation simulation, is upwards of $3,000. Science is constrained by political gain, limited insofar as those with financial means have become the administrators of progress. We need more accessible methods of experimentation. This revolution is being led by frugal innovation, meeting essential needs with simple and accessible solutions. We reviewed designs from 25 published studies and examined ways to reduce cost while preserving functionality. Here, we propose a 30-liter vessel that meets parameters for simulating biomass decomposition at a fraction of the cost of retail bioreactors. The components of the bioreactor were evaluated based on accessibility, being sourced from nationally available retailers like Amazon and Ace Hardware. The quality of the bioreactor was measured by circulating water through the system and adding internal pressure to test for risk of leakage. Further, we can wirelessly measure conditions within the bioreactor by developing a single unit sensor with the Arduino IDE, an open source software.
And so, an early prototype of this Arduino unit, shown in this green rectangle down below, this demonstrates its working principle before its size is reduced in the final form. And so, a second aspect of this frugal design is the water distribution system, which allows us to dynamically model biological processes such as those that are at work in waste degradation. A third and crucial aspect of our frugal design is the gas sampling system, which allows us to take samples of gas that we can measure without any of the expensive equipment that you normally need to use. And so, the cost of the construction of the bioreactor frame, the gas sampling and water recirculation system, and the Arduino sensing unit is all under $400. As we have mentioned earlier, budgets are often one of the biggest hurdles that scientific research has to overcome, and this is especially problematic in the field of waste management. It is often communities with less resources that are disproportionately affected by the global waste cycle. So by designing a frugal mean to research these processes, we hope to assist these communities and return power to those affected. In the future, we hope to continue working on this project by continuously reducing the cost and increasing the accessibility of the bioreactor. We also plan on using this bioreactor design to qualitatively test the effect of textile waste on leachate and greenhouse gas emissions. We plan to construct more of these bioreactors filled with varying types of waste, and we will use the water circulation system to simulate leaching rainfall, and the gas sampling system and Arduino unit will be used to measure the greenhouse gas emissions of the bioreactor.
We would like to thank the Ignite Research Grant from Boston College for making this project possible, as well as those not mentioned in this presentation, Elizabeth Conguista and Sarah Findesine. If you'd like to view the water circulation system in action, feel free to scan the QR code on the bottom middle of the presentation. Thank you for watching, and please email us if you have any questions.